Zach's an assistant professor and program director for exercise and movement science at Lewis University. He received his bachelor's degree from Millikin University and a master's degree from California University of Pennsylvania. His Ph.D. in education technology at Northcentral University. Zach specializes in student learning assessment data, education technology and e-learning, wearable technology, data and analytics, and innovation in sports. It looks like he's going to be doing some moving up here himself.
I'm right now intending to, but
we'll see. So anyway, please welcome Zach Binkley.
How's it going? Let me step out here a little bit. So today I'm going to go over this VERT technology, which is kind of hitting the market the last 2 years. As Scott said, I am at Lewis University, program director and assistant professor. In the absence of time today, if you do have questions or you want this presentation, feel free to email me. I might be able to put this on the website, something like that too. The plan for this presentation, we were intending to do a live demonstration. So what I might try to do is do a kind of a video lecture based on this and show that footage as well. But what is VERT? VERT is wearable technology that is designed to track jump performance. It can keep count of how many times you jump. There's two versions, the VERT Classic. That VERT Classic, that's the one that does the jump load, performance, which is height, and jump rate. That's a little lower level than the G-VERT. G-VERT came out last summer. It's going to help track G-forces as well as the jump load and performance, jump rate, and then it can also go into energy expenditure, efficiency, power. The good thing about the G-VERT, and I'll kind of demonstrate this a little bit, but not too much, with the G-VERTs is you can connect them to multiple places, arms, different limbs, and see what the symmetry is between those groups. It also can calculate your stress percentage as well. So there's three parts to this VERT technology. The one is the actual wearable technology. They are just sensors like this. They go into a clamp like this, and then this attaches to this little belt that can be placed at limbs or at the core. Then the data syncs to a mobile app. For us, we use an iPad, and then once that data is saved on there, it's uploaded through the cloud to the VERT team system. So it is a three-step process. You can do a lot of stuff with this data, which I'll show here in a second. The data here isn't new. We've been using a VERTech at Lewis since I got there about 5 years ago. We do a combine, I'll show that here in a second. We basically measure our athletes and our students with both. And my students have been kind of doing some validation tests on the sensors to see the accuracy of that. That's still ongoing. But this data isn't new. How we collect and especially how we monitor it is. One thing about Lewis it's kind of unique to Lewis, we have men's volleyball. And they get the VERTech out about once a week, and we're slowly starting to get them to use VERT. And men's volleyball, women's volleyball is one of the sports that's primarily using VERT. So with this data collection, you can kind of visualize here the three steps. The first is that wearable technology that's going to collect that data, and that's going to be on the performance side. Then that data is analyzed, and that's the step within the app. And then this is the communication part or the decision action. Now what I like about VERT is that the coach doesn't really need to see that middle part. That's going on live during the actual performance, and then it will kick out what this numbers over here, and that's what the coach will actually understand. So here's some screenshots from the VERT app. It does have a little GPS on it. They have been added new features to the sensor, especially the G-VERT. It calculates your last jump so you can see it in real time. And right there is your count total. You can see average versus average high. These are screenshots from the mobile app on the iPad, a little larger. And again, all this is collected in real time, so you can see and monitor your athletes just by an iPad. I blurred out the names on this one. But this is kind of what the whole team would look like. If you had 10 athletes on the court, or you're in your weight room training on plyometrics, you'd be able to see all of these scores updating in live time. So it's a really good visualization tool for the coach or the trainer to use. On this one, that's from the combine data. I'll get into that here in a second. For us at Lewis, we have kind of trialed this in 3 different areas. The basketball team was obviously on board from day one. Got them involved. We use it for the combine testing, sometimes in practice. We actually experimented this at the urging of VERT to try it on ice hockey. And the physics here are a little different. You get the skates involved. They're obviously not a jumping sport, but we were trying to see the G-force production on each leg as it relates to skating. So that's still kind of a project that we're working on. And then I have about 3 students in my exercise and movement science program who are on the dance team. And since dancing is a jumping sport, we trialed that out and got some data on that. Looked pretty good. Lost my clicker. This is what the website looks like. This is what the team VERT system looks like. And you can see up here, you got your jump data and your G-forces. You can turn both those on or off. They'll change the graph. You have your G-forces on the 40 Gs and then the inches on the max vertical jump. And then again, like I said, you can set up multiple sensors to different parts. You can turn each one on and off. So if you have an athlete coming back from injury during the rehab process, that could be very instrumental in their return to play protocols. There's the Flyret's data. You can see, I think on this one we have 4 athletes in about an hour workout, hour practice, and they had 111 total jumps for an average of 9.6. So as we develop this, as we keep working with this, we'll find out more ways to use it. But just keeping a team view of this data is very important. Here's another view that I erased the names, blurred them out a little bit. You can see energy, power output, stress, load. So one thing I like is when a coach will say the player's not working hard enough or they're dogging it on the court, you can actually back that up and show their data in real time. So who should use this? We see this a lot used in jump dominant sports, so basketball, volleyball, cheerleading, dance, and gymnastics. Wearable technology-based researchers and practitioners can also find innovative ways to use this technology. And then my primary use this last year has been incorporated into our classrooms for exercise and movement science. So educators, learners, STEM and PE programs can all kind of benefit from this technology. So for us personally, at Lewis University, we've used it in 4 classes. My intro class, our clinical and field experience course, data analytics, which we collect data and do some analysis on that, and then our senior capstone works with the client to use this as well. We host a basketball combine for our men's and women's basketball teams every fall to start the semester off. And we've been using this as of last year. We've used the VERT all 3 years, but last year was the first year we recorded data with the VERT. We've done some comparisons. We still need some more data on that. As I showed, we did some data sampling with the Flyrettes and the club hockey team. What was probably the interesting, most fun part of this for last year was incorporating it into the dunk contest. I'll show that here in a second. We're doing some current research on this, obviously, and then we obtained this this set, this whole sensor, 8 sensors, the nice Samsonite briefcase that took me a while to open. We acquired that through a grant to the Doherty Center. And with that grant, we're putting on like a little vodcast series where we'll do some screen captures and lectures on that, and we'll make that available on YouTube. So here's our combine. We do this every year. As you can see, we have a TV set up right in the middle, and that data set is constantly updating. My students they run this whole thing. We have areas set up around the gym and around the recreation center, and each place is a data entry point where we test, and they'll enter the data. And as you can see here, the max VERT with the VERTEC and the VERT was right here in that spot. So as this combine's going on, just like the NBA combine, our players kind of and coaches kind of gravitate towards the screen, and they're able to see everyone's numbers pop up. It's a pretty fun experience. Students like it. And adding wearable technology last year was kind of a game changer for us. At the end of the combine, coaches and players get that printout right there. Performance report gives them all their numbers, and they can track it year to year. Okay, there's the VERT. There's Phil, right there. Good job. Okay, and then so we had the VERT going there, and then we had a table set off to the side, right over here, which had all the sensors charged up, and we're recording that data right there. So I think everyone's seen the VERT. But the idea is when they were going through that test, we also had the data showing up on the VERT, and we were kind of comparing the two in real time. That's just the data set. Another area, my students had 3 students last year take on the responsibility of becoming the performance trainer for our club hockey team. It's not a Division I or Division II NCAA sports club. So 3 of our senior students took on the responsibility of doing pretty much this whole thing. So where we did testing and screening, we did FMS, Wingate test with the Velotron, we did some anthropometric measurements, and we did max VERT. That data was then taken into their strength training and conditioning programming. We did not do nutritional planning. We wanted to do that, but that was a little too much for us. Then hopefully the strength training and conditioning worked with the on-ice skills, and the on-ice skills developed into game performance, which then goes back into assessment and screening, and we started this whole thing off. Like I said earlier, with this VERT system, we tried doing it with the skates. We got some data. Our idea was to maybe put a GoPro on their forehead so we can actually see the strides and match that up, but that has been kind of an issue. It's just not designed for hockey. I understand that, but it's kind of an interesting trial. And then here's the dunk contest. So this was like our October Halloween Madness kind of event, and we had 4 participants, I think, in the dunk contest. They all had the sensors on, they all had it on their waist, and then cheering section was down here, and you can see over here, we streamed the app to a TV, and you were able to see people's jumps in real time. Someone did 42.6, and that was not accurate. everyone started cheering, so it was a fun experience. That was kind of interesting thing about the wearable tech is the culture and the excitement that the athletes get by wearing it. They take it upon themselves to improve, and it kind of just changes the culture of your program. So how you can use it, the big movement right now, I'll talk about this in the next slide, is long-term athletic development, which leads to player monitoring through data collection, and then the sport performance enhancement data cycle, and then lastly, like I just mentioned, culture and team building. So this is the big movement right now in strength training and conditioning, is we're trying to not only look at athletes' current performance, but we're trying to set them up for future success, not just in athletics, but in life in general. We don't want to use up that elbow, the UCL of a 10-year-old in youth baseball. So we're trying to develop that long-term athletic development. You need data to do so. That's one kind of approach to it. So this wearable technology where we can monitor the data to make sure we're not going past our volume is a big thing. So player monitoring, that's where this comes in. The issue right now kind of within sport performance is these are all the movable parts of performing in sports. At the bottom line, you have the decision makers. These are the professionals that will be working on the above parts. You have the analysis line, and then you have the performance line. Now what's the issue with this is there's all kinds of moving parts. And last year at this conference we talked about communication with data and communication across multiple channels. And this kind of shows how your assessment, test, and data, that goes into player monitoring goes into skill development, and it's kind of one big circle. But ultimately the decision maker is that coaching staff. And I know I personally have had some issues with speaking data, speaking analytics to a coach, kind of understanding that. And then there's also, this is just a pretty much an exercise science field issue, is there does seem to be some type of barrier between workouts, assessment, sports medicine teams, and then the actual on-the-court performance. So that's just something to think about. When we look at the performance data cycle, I showed you an example earlier with the hockey team, how it's a circle, and we keep getting data and keep using that to improve. But for sport performance, we base our data cycle really off of periodization. And this is Tudor Bompa's kind of brainchild a little bit. Looking at NSCA does this a good job. You have microcycles versus microcycles, and you got to think your volume for the athlete is going to change at every part. If it's preseason, off-season, active rest, or in-season, their jumps, for example, jumps for the week, are going to look different. But the critical thing is the volume of the athlete's training does change on periodization, and it is something that we can control. Here's some more on this. We got time to get on a tangent on this stuff. But we know that fatigue can set in. It obviously impacts performance, and that fatigue can be caused by overtraining or volume. So on that volume and performance, what is training volume? The NSCA describes it as, for plyometrics at least, it's the number of jumps or foot contacts per session. So let's say you have an athlete and they're completely healthy and your plyometric workout is 130 jumps or contacts, that might be appropriate for that athlete. However, you have 15 athletes on a team and 2 of them are on ACL rehab. They're not going to be able to do 130 jumps, or they shouldn't be doing that in that amount of time. And we know that overuse injuries are often a result of poor training load programming. So for this, okay, let's say the athlete is limited to 75 foot contacts per practice session. Obviously 75 would be there, and we would want to stop them. The issue that I've ran into both as training athletes and talking with others that have trained athletes is if you have 15 athletes and you're going through all these plyometric workouts, you're doing this entire thing, 30 minutes, 130 jumps per athlete, there's no way that they can keep track of everyone's jumps. So that's where this system can kind of come in play, is that you would have this system up, it would show you everyone's jumps. Once athlete C, who's on a 75 limit, hits that threshold, you stop them and program that way. So an example here, needs analysis, you have 4 athletes, they're all different, okay, sport specializations. This is the big thing that we're trying to look into, is everyone's body's different, everyone's goals are different, their outcome, position, so everyone needs to be treated in a specialized way, and that's hard to do, but I think technology can help with that. So obviously, basketball people in here will know probably all these references, but over here, airbud's the issue. Limited to only 20 to 40 total touches per workout. And again, if you don't keep track, that's an issue. So this is what it would look like. Obviously, airbud went over that threshold, and he might be at risk of re-injuring himself. So takeaways with this, wearable technology is great to use for long-term athletic development. Player monitoring is more available now than it ever has been. But just don't collect data just to collect data. Have some kind of purpose, be able to communicate it. If you can't communicate what the analysis is, it's kind of useless. And again, paralysis by analysis can happen. That's why I like this VERT system, because it just, the coach, if they want to see the total jumps in practice, that's good. You can be as simple as you want, or if you want to show G-forces produced by the right leg versus left leg, you can get advanced with that as well. And I kind of always say this in my analytics lectures, is that we have to know who the decision maker is, we need to know who this data is going to and how they're going to use it, and making sure that is appropriate for them. So if there's any questions, we have time after this.
We got about 5 minutes for questions.
Or if you want to come up here and try these out, look at them, have at it.
I guess I'll leave it up to you guys. You want to ask questions, or do you want to come up and see what Zach brought in his heavy-duty briefcase? Any questions first? All right. Well, thanks, Zach. Feel free to stick around here. The next talk in here will be at 10:45 as well as in the other room. Thank you.